So what's the difference between an integer exponent and a rational exponent? Well, an integer is a number like -1, -2, -3, 1, 2, 3, but a rational is actually a fraction. So really all we're doing is we're replacing our exponents with fractions and we're going to try and solve those. Just a couple of terms for you so you know what we're dealing with. We still have a base and the exponent is still called an exponent, except this time all of them are going to be fractions. And then we can have a big number in the front and that's still called a coefficient. We are going to learn to write our rational exponents in two different ways. So if it's written in the way at the top, that's called exponential form. And that's sort of the form that we're used to seeing, right? When you have a base and an exponent. But there's another form, and that's called radical form. And we've all seen the radical sign before because we've dealt with square roots. But in today's class, we're actually not going to be dealing with square roots. We're going to be dealing with other types of radicals. So here is what we're going to do. Whenever you have an exponent that is a fraction, this number over here, the numerator, stays with the base, but the denominator becomes something called an index. And you write the denominator as a little teeny tiny number somewhere on the left-hand side of your radical sign. And then the coefficient is just going to be all the way in the front. We've actually seen this done before. So you know when we have something like the square root of 4, there's an index there that we don't write, but it's always said to be there, and it's actually the number 2. So every single square root sign, so whenever you have like the square root of 16 or the square root of 25, there's actually an index of 2 that we don't write. It's kind of like, you know, when we have an exponent of 1, you don't have to write that, or a coefficient of 1, you don't have to write that. The same rule for an index of 2, you don't have to write that. So technically, if we were to take these radical forms and change them to exponential forms, what you would do is, this is like saying 4 to the power of 1, and you could rewrite this as 4 to the power of a half. Because remember, the numerator goes, the number attached to the base goes as the numerator, and the index, which is on the left-hand side, goes as the denominator. This would be rewritten as 16 to the power of a half, and this would be rewritten as 25 to the power of a half. These are all exponential forms, and these are all radical forms. Now, you're obviously not always going to have an index of 2. You can have an index of anything, but the rule still applies. You take the number or the exponent attached to the base, that's the numerator, the index is the denominator. Okay, we're going to get lots of practice doing this. So if you feel confused, don't worry, we're gonna do a bunch of questions. This is basically what you need to remember. X to the power of 1 over n is the same as root x with an index of n. Let's start by actually skipping question number 1, because I actually feel that question we'll need to do after we know a little bit more about the different forms. So we're going to go right to question number 2. Yay. What we're going to do for each of these is we're going to write them in exponential form. So they're all in radical form. For question 1, no number is given to you. It's just a square root sign. So whenever you see that, you should know that there is an index of 2, and there is it's actually 14 to the power of 1. And even though those numbers aren't written there, they're always there. So when you rewrite this into exponential form, you start with your base, which is 14. You take this number, and that's going to go in your numerator, and you take this number, and that's going to go in your denominator. So it's going to be 14 to the power of a half. Okay, so for question B, we have an index of 3, and if there's no exponent written, we assume it's a 1, like 5 to the power of 1 is the same as just 5. And so when we rewrite that, the base is going to be a 5. What do you think our exponent is going to be? 1 over 3. Good. Remember from last class that brackets do matter when you're talking about power, so you have to be really careful. In this question C, the entire base is -6, so you have to make sure to keep brackets around that. But other than that, nothing else changes. So we're going to have a base of -6, and then what's our fraction exponent going to be? 3 over 5. If you did not include the brackets or in the -6, you do change the value of the question, and it is wrong. So make sure that if the base is in brackets, you also keep it in brackets. I'm having a hard time writing. And then for the last one, ooh, this one's a really good question. So do you guys notice that we have a negative and then the actual base in the question is under the radical sign of 117? You actually have to keep those separate. So what I would do is I can actually rewrite this as -1 times, and if we wanted to rewrite the 117 with a little index of 9, I could rewrite this as 117 to the power of 1 over 9, all to the power of 3. So what I've basically done, oh, and I know what Rahiman's going to say. He can't see this. Sorry, I always forget. Is that a little better? How about that one? So all I've done is I've recognized that the negative is actually a coefficient. -1 is not a part of the base. So I kept the -1 separate times. I changed this number over here into exponential form. And I just assume there's a little 1 here. So it's 117 to the power of 1 over 9. Now what I'm going to do is I'm going to take this 3 and I am going to distribute it and apply it to both of these terms. So really what it's going to become is -1 to the power of 3 times 117 to the power of 3 over 9. And you're allowed to do that. You can take an exponent on the outside as long as everything's multiplied together, and you can distribute it to all the terms in the bracket. -1 to the power of 3 is just -1 times -1 times -1, which is going to give me a -1. So just a negative sign. And then this is going to be 117, and 3 over 9 can be reduced to 1 over 3. So my final answer is going to be negative bracket 117 to the power of 1 over 3. That's a little bit tricky because I have to do a couple of steps. So just make a note of that one, that example. Is this okay though? Changing from exponential to radical form? Are we okay with this? Yes. So why did you separate negative from non? So for question number 3, we're now going to write each of the following in radical form. So we're basically just doing the opposite. You identify the base, and that is what goes inside your radical sign. Remember, the numerator goes with the base, and the denominator is an index, so it goes here. But do we need to write the index of 2? We don't have to. And do we have to write an exponent of 1? We don't have to. So really, if you wrote this as just root 12, that would be correct as well. Is it okay if you write an index of 2? Of course, you won't get marks off, but both of these are correct. Marks off? For the next one, does the 1 over 4 apply to the negative sign? No, that negative sign is completely far away from this question. So you have to keep the negative in the front. The base is only the 9. So the 9 is going to go inside my radical sign. The 1 belongs with the 9. And the index of 4 is what's going to go on the left-hand side of your radical sign. We don't need to write an index of 1, or an exponent of 1. So if you wrote it like this, it would be correct as well. Okay, go ahead and try the next two yourselves. I'll write the answers here. Well, you can definitely put it in brackets, or if it's under the radical sign, I assume it's all together. So if you wanted to write this as -10 bracket radical sign and then the 7, you could do that as well. Either way is correct. So radical sign, bracket, -10, bracket, bracket, and then a 7. And then the same thing for this question. I realized we skipped number 1, and that actually was talking about this. You can write this in one of two ways. You can write this as -13 to the power of 4 index 5, or you can write it the other way. So that 4 can go inside with the -13 with the base, or it can go outside. It still represents the same thing. Show you how to do them. For question number 4, it says evaluate each of the following, express answers in rational form. So we want to make sure we have our answers in rational form. And we don't have calculators. So if we had a calculator, this would be really easy. We would go 16 to the power of 1 over 4, or 0.25, and we get an answer right away. But we need to figure out a way to solve this question without actually using a calculator. So what we're going to do is, my strategy here is I'm going to look at the base, which is 16, and I'm going to try and rewrite the base as a power. So like another base and an exponent. So if you take a look at your exponent charts, or just from like your knowledge, can you think of what to the power of what is equal to 16? 4 to the power of 2, right? 4 to the power of 2 is equal to 16. And I think there's another answer. So what else is equal to 16? You could take a look at your exponent table. There's one other power that equals 16. Ariane? 2 to the power of 4 is also equal to 16. Technically, we could use either of these powers to solve this question, but there's a smarter choice. And that smarter choice is you have to look at your exponent, and you have to look at the denominator of that exponent. If the denominator is a 4, it's smarter to use the power that has an exponent of 4 as well, because then your exponent is actually going to disappear. So I'll show you what I mean. I am going to replace the 16 with 2 to the power of 4, right? Because we all know 2 to the power of 4 is 16, so we are just changing the way it's written. All to the power of 1 over 4. Everyone's with me? Everyone see what I did there? Okay. Now, according to my rules of a power, I am going to go ahead and multiply 4 times a quarter. What is 4 times a quarter? It's just 2 to the power of 1. And that's why if you very strategically pick a power to replace your base with, and you can actually make the entire fraction disappear, and the question becomes really easy. The answer is just a 2. Let's say we were not so strategic. Let's say we didn't think of 2 to the power of 4. We just thought of 4 squared. So let's solve the question again. And this time, let's say we pick 4 squared. So 4 squared to the power of 1 over 4. Okay. What is 2 times a quarter? A half. Can I replace the 2 with anything? I mean, the 4 with anything? Do I know a power that equals 4? 2 to the power of 2. So I'm going to have to do this again and replace the 4 with 2 squared. And what's 2 to the power of a half? Sorry, 2 times a half. 1. So eventually, we do get to the same answer, but you can clearly see that one of them took a lot longer than the other. And that's why if you pick a really strategic power to replace your base with, it makes the question so much easier. But either of those is correct, you would still get the same answer. How are we feeling about that example? Do we kind of know what we're doing? Yeah, okay. 27. So again, take a look at your chart, or can you think of any power that gives you 27? Rahiman? To the power of? Yeah, good. So I'm going to replace the 27 with 3 to the power of 3, all to the power of 1 over 3. And by the way, there's no other choice here. Nothing else equals 27, so it's really just those two that number. 3 times a third is just a 1. And so our answer again is just 3 to the power of 1, which is a 3. Not too bad, right? Okay. Let's keep going. So for this question, I have -0.5, which is a little annoying. That's okay. We can actually rewrite this question. So it's 25 to the power of negative 1 over 2. I feel decimals are really confusing. So I prefer fractions. Can we think of a power that we can replace 25 with? You were right. Yeah, 5 to the power of 2 times negative a half. And that's really the only option. Nothing else gives us 25. 2 times negative a half is negative 1. And remember, having a negative exponent is really poor form. So we want to rewrite that without the negative exponent. Our answer would just be 1 over 5. All right, let's keep going. Negative 8. That's a little weird. You know what? Let's just pretend the negative sign's not there. Let's just look at the 8. What power can we replace the 8 with? Ariane? Yep. No, because 5 to the power of negative 1 is not equal to 5. It's actually equal to 1 over 5. So you have to make sure to keep it as 1 over 5. Yes. If you kept it as 5 to the power of negative 1, you would lose marks. Never have negative exponents in your answers. It's really poor form. Can you guys think of anything to replace the 8 with then? Yeah, okay. So we know 2 to the power of 3 is equal to 8, but unfortunately our base is negative 8. That's not a problem though, because negative 2 to the power of 3 is equal to negative 8. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So if you're dealing with negative signs, ignore the negative sign, figure out what the number would be with just as a positive, then add the negative later. Yes, you do. If you did not have brackets around the negative 2, it would still be negative 8, but then it gets kind of tricky because then like it's not part of your base and you want to make sure to keep it as part of your base. Okay, so we now know that we can replace our negative 8 with negative 2 to the power of 3, all to the power of 2 over 3. I'm a big fan of like multiple styles of brackets, so you'll see me use like rounded and square. What is 3 times 2 over 3? Well, 3 times 2 is 6. 6 divided by 3 is just 2. So this reduces to negative 2 to the power of 2, which would just be a 4. Am I going too fast or are you guys okay? We're good? All right, let's keep going. 4 more examples. Okay, for the next example, we have 64. So there are actually a couple of options for this. What do you guys see on your chart? 8 to the power of 2 is equal to 64. What else? 4 to the power of 3 is equal to 64. And there should be one more. 2 to the power of 6 is equal to 64. Okay, so when we have multiple options, I list them all down. And again, you want to pick a smart strategic option. You look at your exponent, you have 5 over 6, and we want that exponent to disappear really quickly. So which one of these options would help it disappear? Exactly. So even though all of these answers would work, the smartest option would be to go with 2 to the power of 6. So we're going to replace the 64 with 2 to the power of 6, all to the power of 5 over 6. 6 times 5 is 30. 30 divided by 6 is 5. So we're going to get 2 to the power of 5, which is equal to 32. Question F, G, and H, we're adding a little bit of BEDMAS into it, but nothing really changed. Like it's still all the same concept. So according to BEDMAS, remember you got to do brackets first. So 27 plus 9 is going to give you 36 to the power of a half. We can replace the 36 with 6 squared, all to the power of a half. 2 times a half is just a 1, and so you end up with just the number 6. By the way, this is the same as writing it, bless you, as writing it as square root 36, right? Anything to the power of a half is the same as just the square root sign. So you could have just identified it that way and also just written 6. Okay, question G and H are definitely the most challenging. Let's try question letter G. So first of all, we have a random negative exponent. I know what I need to do with that. I'm going to change it to 1 over 9. Okay, now we have 8 over 27, a fraction that can't reduce, all to the power of 2 over 3. What I'm going to do is I am going to eventually use our little quotient rule. We're going to apply the 2 over 3 to the numerator, and we're going to apply the 2 over 3 to the denominator. So as my first step, I'm going to go ahead and rewrite them. So the 2 over 3 is sort of split up with the numerator and denominator. So we're going to have 8 to the power of 2 over 3 and 27 to the power of 2 over 3. Okay, now you're kind of treating the numerator and denominator as 2 individual questions. You're going to replace the 8 with a power. What power would that be? 2 to the power of 3. And you'd replace the 27 with a power, and that would be 3 to the power of 3. We've actually done both of those numbers for question B and D. So what's that going to look like? It's going to be 1 over 9 plus, this will be 2 to the power of 3, all to the power of 2 over 3. And this would be 3 to the power of 3, all to the power of 2 over 3. Maybe that's what I need to do. It's so hard to write little, maybe I'll write them like this. It's kind of better. Okay, now for the numerator, 2 over 3 times 3 will just be 2 squared. And for the denominator, 3 times 2 is 6. 6 divided by 3 is a 2. So this would just be 3 squared. I'll pause here. Does everyone see where I got the numbers from? Yeah? Questions, comments, concerns? No, we just solved this. So this would be 1 over 9 plus 4 over 9, which would be 5 over 9. Go ahead and try question H. I think it's the most challenging. Start with BEDMAS. So solve what's inside the bracket first, and then do exactly what we did with the whole negative 3 over 2. I'm going to do attendance. We'll take it up in a second. All right, so for this question, we will begin by solving the inside the bracket. I can find a common denominator by multiplying the 4 by 25. Whatever I do at the top, bottom, I have to do at the top. So this is going to be 25 over 4 minus, 25 over 100 minus 9 over 100. And this is all over negative 3 over 2. This then becomes 16 over 100, all to the power of negative 3 over 2. Now, what you could do is you could reduce the fraction inside. Some of you might have done that, but I recognize that I can actually change 16 and 100 to give me a power, right? So maybe I'll just do that. I'm going to change 16 to 4 squared, and I'm going to change 100 to 10 squared. So this is going to be 4 squared. This is going to be 10 squared. And then I'm also going to distribute the negative. Oh, actually, no. Sorry. Before I do that, I want to get rid of the negative sign. So remember, when there's a fraction, to get rid of the negative sign, you just flip the numbers around. So maybe I'll do that first. I will go 100 over 16, all to the power of 3 over 2. Now I don't have to deal with the negative anymore. Sarah? You could, yes. You could have, yeah. Yeah, because that's still 2 squared and Yep. Yep. So if you want, we could go that route. We can actually reduce this fraction to 25 over 4, all to the power of 3 over 2. And now from here, I am going to replace the 5 with 5 squared, all to the power of 3 over 2. And I'm going to replace the 4 with 2 squared, all to the power of 3 over 2. So now this is going to give me 5 to the power of 3, and this is going to give me 2 to the power of 3, which means my final answer will be 125 over 8, which cannot be reduced any further. If you hadn't reduced the fraction, it would still work. You just have to reduce your final answer a little bit more. Either way is correct. 5 over 2? I don't think they're divisible.